Hi everyone, welcome to Toronto Workshop. Today we're very pleased to be joined by Zora Wang from Carnegie Mellon University. She is a PhD student at the Language Technologies Institute at CMU. She works with Daniel Freed and Graham Neubig. She also works closely with Diyi Yang at Stanford. And her research interest is on using programmatic approaches to solve real-world tasks. And today she's going to be talking about AI agents at work. So thank you very much for joining us, Zora.
Yeah, thanks for having me. I'm very happy to talk about my recent works on building AI agents. We're analyzing AI agent development towards human work. So today I'll be featuring two of my recent projects, but they're all related to the same big topic of building AI agents for human work. So I'm sure you probably already seeing a lot of this progress either by articles or posts online that you've seen a lot of benchmarks where agents built towards optimizing some part of human work. And I think two big trends that I'm seeing, one is getting information, where a fancier term is deep research. So you see this different benchmarks, Browscom, Web Voyager, or even models, Dr. Tulu that try to automate this part. And similarly, there's a big trend that maybe even bigger for software engineering tasks. This could be like Sweetbench. I think almost everyone who's doing coding agents is valuing on it. And there are different agent architectures, Sweet Agent, Open Hands that try to automate this task. All this seems like a very big thing, but actually, let me just put the surprising finding in our first work here is if you actually look at how much these two tasks, like how much human employment or economic value they take in the entire labor market, they only capture around 5% of human work. And there are actually other 95% of human work that we haven't really touched on. But the general feeling of an entire community are given is like, oh, we're very close to AGI and we're automating a lot of human job. So let me dive into how we get this finding. So to start, I think the most important part is we actually need to understand what is human work. How does it look like? And also, on the other hand, how is the agent development effort been so far? And for our approach, we first start with depicting human work by introducing different taxonomies to understand the structure and distribution. And then we're aggregating all the agent development effort and try to map to that space of the real world landscape so we can have a fair comparison. So to start, we're utilizing data on the ONET database, which captures all the occupation in the US labor market. They have this annotation of different work industries or basically domains, and then occupations in that domain and what tasks are required for each occupation. So we adopt two taxonomies from it. One is the domain taxonomy that starts with different industries and then branches into different occupations in that industry. And this is more about the industry distribution. And then separately, we're orthogonally, there's another taxonomy which features cross-occupational skills, the four big categories that they annotated is information input, mental processes, interacting with others, and work output. And you get more fine-grained skills required by each of these categories, and it goes on to multiple layers. So eventually, we use these two taxonomies to describe or depict the landscape of human work. So one is depicting under what context and what domain knowledge do human need to acquire to do this kind of job. And then on the other hand, what are the cross-occupational skills required? And because human employment or capital are not equally distributed across these different categories, so what we do is we also port data that feature human employment in each of these occupations and related to each skills. And also the economic value or the way that we estimate it is we look at the annual wage of these different occupations and we just allocate those based on what domain or what skill they're contributing to. And after we have this general structure of human work, we now look at on the other hand, what's the agent development effort so far? So what we did is basically aggregate all of the agent benchmarks so far, or at least the most representative ones. And this could be categorized into multiple general categories. I think one big thing is like software engineering, and there's some other ones about like web or like mobile navigation, and some particular ones on AI for science too. But the other domains are just like very scattered. Like there are one or two benchmarks on like planning or like information seeking tasks. But overall, we got like 43 benchmarks of that representing like agents or related to work. And then overall, they have like over 70,000 tasks in general. And what we do is for each of this task instance in each of the benchmark, we map them to the two taxonomies that we introduced. So one is we map them to a path in the domain taxonomy, starting with what domains are featuring and like what occupations reflecting, and also specifically what tasks related. And on the other hand, also map each example to a path in the skill taxonomy. So starting from like very coarse high-level skills to gradually more fine-grained skills of like decision making and then maybe like information seeking and stuff. So now we have this mapping. We can basically plot the distribution of agent development effort estimated by the benchmarking effort so far in the same space of human work. So now we can actually like look at the differences and see where do they align and where do they misalign. So as you can see from this figure, there's a very heavy concentration on computer and mathematical tasks, as is very expected that you see a huge amount of math reasoning benchmarks and a huge amount of software engineering related benchmarks. But however, I think this is good for automating particular this domain, but it's like actually also surprising to me how much people have been overlooking the other domains. For example, if you're looking at domains where like there are most people working on it, like that has the highest human employment, then you see this very common task of like office administrative tasks or like business finance operations. But there are some, but not a lot of effort on it. And also, if you look at on the like capital centralization part, there are domains that like if you invest in more, if you can automate that kind of job, it will be you have like greater opportunity to get high returns because people usually like get more salary in those domains. But this also happen to like overlap with a lot of domains that are like very heavily digitized. So it's like actually a perfect scenario for us to build AI agents, but also surprisingly, no one's actually building agents for it. Or another motivation of like building better agents is to uh, like free up cheap human labor so that human can do like more advanced or like valuable tasks instead of always doing the mundane boring tasks. And this could usually maps to the ones that have like a lower income, but also there are like very little effort in those. So those are just depiction across different domains. And if we look at the distribution across different skills required in human work, on a very high level, it seems slightly better. But there's still one like category of activities which is interacting with others that are very underrepresented. However, this is not the full story. Remember that we have like skills of very granularities. So if you actually look at deeper, like finer grained skills down the path, you'll see most of the effort are actually spent on just these two very fine-grained skills, whereas other skills within the same bit categories are rarely represented. As you can see, some of them have like even zero benchmarking instances. And this actually maps pretty well to what we're seeing online, the big trend on like tasks about getting information or software engineering. So overall, there's still a very heavy imbalance between the different skills that people are optimizing towards. And lastly, what I want to put out is that although we're like mapping this benchmark examples to certain domains or skills that are related, they only mark a relevance, not that they're representative of the work that humans actually do in these domains. One analysis we do is like we're evaluating how many like domains, where like how many tasks are mapping to each of the benchmark examples are mapping to. You can see most of the benchmarks have very limited domain breadth or skill breadth, and they're just like very simple tasks. Like, for example, if they're related to sales, it's just a simple like math related to a sales scenario, but they're like much less complex than what salesperson are actually doing their work. So I think overall the finding here is that I would like to acknowledge the current benchmarking and agent development so far because it has brought us very good coding agents. But I think people have been focusing too long on just very easily verifiable tasks or tasks that are easy to specify the instructions like math and coding, but people have been like staying away from the hardcore thing like for other type of work if it's very hard to come up with verifiable rewards, and if the correctness of a task is like multifaceted, people usually are avoiding doing that or like kind of are avoiding doing that. And I think that's still an open but interesting problem to think about how to get verifiable rewards or like evaluate the quality of work in other domains. For example, if you're generating a spreadsheet, then what matters not only the correctness of number in the spreadsheet, but also like people care about how the data is formatted. Are they using the color that like conveys a sense of like professionalism, or there are other regulations or preferences in a certain work context? Um, so I think that's the takeaway from this portion of work. I see some questions in the chat already, so maybe I'll just pause here and take
Okay.
questions or I'll answer them
All
first.
right. Thanks, Zora. I'll just read out a couple.
Okay.
So it's just if we start to deploy AI LLMs for office and administrative support. Oh, okay. Yeah, there's some thinking about potential for layoffs and things. Okay, has CMU deployed LLMs to automate administrative works, for instance, decoding applicants' transcripts to JSON format?
Oh, the yeah, I think for the second question, hi Jason. I'm not entirely sure if staff are doing this. I think from just talking to people at CMU, I think mostly is students and professors adopting the language models. I don't know how much like staff are doing this. Um,
Well, I'm asking because we are about to, implement this approach at U of T right now. So I just want to know if the other university have done the same approach already, so we can learn from each other. Um, so right now we are, doing very much manual works to, reading their transcript and manually input the data to our CRM system. So we want to see if we can deploy any large language model to, decode anything, to automate the whole steps.
yeah. Yeah, that's an interesting application. I think from what I know, people are not like massively using any of those systems. But I do remember because there are a lot of startups like interested in agents, so I've been just talking to a lot of them. And I think some of them are like thinking of like building um specific well, like AI agents for certain applications, like fill out a form or like like you said, like transcribing some of the information. But I think it requires a lot of specialization to like what system you're building because it requires like at least special prompting to the language model to make it work and
Yeah.
navigate through the different sites. Yeah, but like I'd love to know what you guys are using and like how it turns out, and if it's useful, I'm happy to try to publicize and
Well,
see.
yeah, I've done some tests.
We should, Jason, we
Personally.
should maybe just keep moving
Yeah.
and maybe we can come back to this at the
Oh,
end.
sure, sure. No problem. Yeah.
Yeah.
Thank you.
Should
Zora,
I?
do you want to keep going and we can, I think this is a question about evaluation, so we could, that'll be relevant again in the end, maybe.
Okay. Yeah, I can go on for the rest of the presentation and leave more questions in the end. So yeah, this is the first chunk of work that we're like looking at from a holistic point of view, how the distribution of AI agent and human work aligns or misalign with each other. And I think, and the further question is, even on the domains that AI are currently targeting, how are they performing? Because I think a lot of people are just curious, oh, will AI take my job? And how good are they compared to humans? And there have been some efforts, including us, to build this benchmark called the Agent Company. They're like annotating a bunch of very complex tasks, featuring different kinds of human job. And you can see this models. This is like later 2024, so the models at that time were not as good as now there are, but they're still achieving pretty kind of good scores on some of the domains. Although you'll see like you can't expect the scores of human performance to be better across these different domains. So a lot of people would be excited about this number saying, oh, agents, if we keep improving, if they got 100 scores on these domains, would they just take human jobs? And I think the answer for me is like still not a hard no, but like it's very hard to tell. Because I think one thing is we're thinking of like using agents to replace human workers. We never actually like compared human agent workers head to head, and we're just like evaluating agents in isolation on some tasks we created. So what we did is, in the earlier work that we did last year is we're doing a head-to-head comparison of AI agents and human workers across different kinds of tasks that people do of different occupations. And we're analyzing their workflows and their work outputs, their efficiency, the multiple aspects of work, and try to have a holistic evaluation of human and AI performance. So what we did is like we want this study to be informative to possibly like a larger group of human workers. So we actually want to feature multiple occupations. But from the database on ONET, if you have looked at it, it has like thousands of occupations, which is a little bit hard to scale. So what we did is to look at the occupations and their task requirements, and we identify the shareable skills across different occupations. And the five most big categories that we find is data analysis, engineering, computation and administrative work, writing, and design. And although we have this high level of skills, we do want to ensure like sufficient coverage on like different domains executing the skills. So we're creating multiple different instances to try to touch on different domains, but requiring the same skill. For example, for data analysis, we're creating like finance data analysis or like HR analysis and like checking attendance data. For like writing, we're like having HR or like just administrative writing, but also like financial quarterly report writing. So in total, we created 16 task instances, and each of the tasks would take like human workers around 2 to 3 hours to finish. And now, next step, what we do is we hire human and agent workers. So for humans, we actually look for professionals who have like sufficient education and professional experiences in the skills in the domains that we're testing on. And on the other hand, we're testing the most popular, like best performing agents at that time, including general purpose agents like ChatGPT agents or manuals, and also some like open source counterparts where like that has better coding abilities, which is OpenANS. We're also testing with different language model backbones, so hopefully it's like somewhat fairer comparison to this ChatGPT and Manus agents who are using this GPT and cloud models. So what we do is like for each task instance, we have like multiple human workers trajectories and multiple agent workers trajectories. So the next step we do is to analyze their trajectories and the final task outcome to compare like, what's the same and what's different, what's the respective advantages of different kinds of workers. However, one issue that we encounter in the beginning is actually, if you look at the trajectories that humans and agents do is like very messy because these are just how it prints out when we're like recording human activities. If you record human activities, you're basically tracking their mouse and keyboard actions, which requires a lot of interpretation. For example, click on this numerical coordinates, like very hard for human to interpret and very hard to do analysis over. It requires a lot of post-processing on the keyboard presses because if you just type a bunch of things and you just like delete a bunch, so like human actions in general are very messy. So we propose for to like enable better analysis is we propose this workflow induction tool that basically brings the low-level noisy actions of both human and AI workers to an interpretable hierarchical workflow. So basically you can see we interpret the intention of these activities and group them like into a hierarchy of steps so that basically first for us to analyze the data is easier to understand, but also you can choose like which level of granularity that you hope to get into to just fairly comparing tasks or activity at the same granularity level. And so we can do this not only for human worker activities, but also for agent activities. So in general, what we end up getting is a unified representation of human and agent workflows, and they're all represented in the same format on the exact same instance, so that enables us to do fair comparison. And I think like preliminary or like the fundamental step of this is basically to see like how much do human and agent workflows align with each other. So we're like design an automatic matching procedure to see like what steps, like for example, step one in human workflow and step two in agent workflow maps to each other. And like you can also further calculate like qualitative values from it to like just as a report a score of like how much human agent workflows align with each other. And very interesting after that, I think there's a lot of like further extension that I've seen people using the toolkit. For example, for some people at companies that are interested in like adopting AI, but they don't know like what their workers' workflow look like or which steps should I deploy AI. So this could be a tool of just understanding your workers' activities and spot where AI could come in to help. And others, I've also like collaborating with other projects that, we can use this as a tool to see like how humans are relying on AI, like which step are driven by human, which step are driven by AI. So coming back to our analysis, now we have this general workflows and we can get to analyze them and see how our agents doing our jobs in comparison to human worker. So first on the workflow alignment level, it's like a little bit surprising to me that actually human and agent workflows are actually pretty aligned. It's like around 70 to 80% of alignment across the broad range of tasks we're doing here. And I think that's a promising sign because then you can see that actually agents are doing the work and the similar procedures humans do, so they're more like compatible with each other. So it's easier for AI to be integrated into human workflows. However, if you look at a deeper level to see like how human agents are achieving the same step, you see a bit difference. Because let me just show you a few examples. For example, in data analysis tasks, most humans will like choose to interact with the spreadsheet and click the data cells, but agents always program like using some libraries like pandas and NumPy. And this is even true for like slide presentation tasks that people would just click on the Google Slides or Keynote, whatever software they're using, but still agents is generating programs. And what's very shocking is that for even like a logo design and interior design, this like very heavily visual oriented task that as a human, I couldn't imagine me doing that by writing programs. Humans, you can see obviously using this visual interfaces, but agents always write programs to do it. So I think this signifies a very distinct approach of how humans and AI are approaching the work. Like humans prefer like visual interfaces, but agents would prefer like program-centric approaches. And this might be partially affected by, how we're building models now. It's like a lot of people are interested in coding tasks, and these models have been trained on a huge portion of coding data. That might be driving this behavior. Um, but in general, this is the scenario now. And this has been like leading to some issues in the outcome of the work. So if you see the end task outcome performance, you see humans still have a very huge margin compared against different agent architectures, despite the like most powerful ones at that time can only achieve like around 50% of success rate. And one issue, particularly that's like prominent to me, is agents often pretend that they do the work. So for an example, this task asks the agent to look at the image of the receipt and then put the data entries in an Excel sheet and then return that Excel sheet. And you can see from the trajectory that agents like doing the steps is open the receipt image and then it's creating a Python script to put data into the Excel sheet and then port it out. But actually, if you look at the data, it's all hallucinated or like fabricated. That's none of those entries are actually matching any of the entries in the received images. So like from the outcome, it looks very good. Like, oh, you asked for Excel sheet, I give you Excel sheet. You have 5 receipt files, I give you 5 entries in my sheet. But actually none of the data are actually correct. So it requires very careful human verification, maybe in the middle or at the test end to actually spot this error. Of course, there are also like other issues with agents that sometimes, especially related to visual tasks, they're just not good enough. You can see like you can very easily tell which line is AI generated and which line is human generated logo because yeah, I will just not this do not need like further explanation. And there are also under analysis are also other very common failures for agent's task outcome. Sometimes it's like computational errors if it involves like more complex stuff. And sometimes it's like, I think partially due to the preference that agents have to generate programs to do things, they're preferring certain file formats like markdown files or just TXT files. Those are just easy to write with program. But humans like generate a lot of things in like PPTX or docs or other like more human tailored data file formats. So like agents are very having a very hard time of like transferring files from like markdown to docs files, which are more human friendly. However, humans may solve the work with better quality now, But agents do have its benefits on it actually can solve the task much faster. And particularly if the step can be very easily automated by writing programs, say just like cleaning up a data file, then actually agents can do that step correct, but like much faster than human workers. So across all of our data points, agents are, if you measure by the number of actions a human and agent do, agents are like 80 to 90% faster than humans. And one interesting thing is that we calculated the cost of like hiring a human worker in our study. And hiring, we're like just calling this language model like that's the price of hiring an AI worker. You see that this AI worker is actually over 90% cheaper than human workers too. So there is some promising signs that if the agent can do it correct, there's some motivation of actually using AI to automate this step. However, or another interesting aspect is when we're looking at human activities in solving this task, we already find some of the humans using AI already. Like 25% of human workers in our study are using AI to do this task. And we spotted two patterns. One is like we call it augmentation, where particularly human are very clear on their workflow of the task. So they just use AI agent for a particular step. For example, for designing a logo, previously people are using Google search or like Figma repository to look for resources for design insights. Now it's just asking a language model instead to do that step. So AI in that scenario is a tool in replacement to other tools that they're using before. And another scenario is automation. And this happens more often for people that are more junior level that do not have like so much expertise. So what they do is they just hand off the entire task to the agent and have agent plan the workflow and do everything. And what we observe is actually if people are deliberate, have like a particular goal of what they're going to achieve with AI and they have this AI utilized in a particular scenario, it's an augmentation case, we observe a speed up, like almost on average 24% of speed up in the humans activities. And because humans are controlling how they're using the AI, so the AI usage is aligning with the human workflow. But for the other scenario where humans don't have deliberate control on how do they use the AI and just let the AI to for free do anything, we actually observe a 17% slowdown in the human work and actually is causing a lot of disruption. So one illustration is on the top is like a workflow of how an independent human would solve this task. You see now if you're asking models to do it, then they'll do the work for you, but it requires extra steps for the human to review or like transporting different files or like even debug things. And that actually costs human extra time to just, understanding the context of the agent task solving process and like even try to like fix things. And actually, I think what we find to be an effective strategy in the end is if you look at what humans and agents are good at respectively, humans are producing work at higher quality, but agents are doing things at a faster speed. So particularly on steps where, agents are struggling to do and they cannot do it correctly, humans will take the steps where like we have to have humans take the steps. But if there are other steps that, I think in this example is like cleaning data, which is requires a lot of manual effort to do. And agents can do it reliably well by writing programs. Then there's a high incentive for us to just delegate that task to agents. So I think or at least the current best way of utilizing AI agents now is not to have them like automate entire very complex tasks, but is to spot the steps, like find the right complexity level of the task for agents to automate on that particular step. And human can like, more effectively supervise things without having to spend a lot of time a lot of manual effort on doing some low value steps. And I think the major takeaway from this is also, even though we can build agents that, can automate like a 2-hour task, but I think we don't have to deploy agents like that all the time. At deployment, regarding like to house the respective advantages and skill profile of human and the agent, you can choose the right level of agent autonomy to like best utilize their potential. So we do like back to our initial big picture of like connecting agent development to different human work. We're like now thinking of like, how should we decide which level of agent autonomy we should go to? And that heavily depends on actually the complexity of the task. So we're bringing back this workflow architecture and actually utilize it to measure the task complexity by the number of granular or the most fine-grained workflow steps in that hierarchy. And basically, we get from all the agent benchmark examples that we collected in the beginning, we collect all the available agent trajectories on those task instances so far. We categorize these different tasks by their complexity using our workflow step measure. And now we can basically depict, the average success rate of agents across tasks at different complexity levels. And this is a holistic number. And we're defining this basically as the autonomy curve. And you can see, like for tasks at different complexity level, how does agents' correctness or success rate change? And like it just gives you more like empirical sense of like what this different levels means. For example, at level 3 or 4 is like easier of like implementing a specific function like a rollout loop. But for more complex tasks, like at level 15 is like implement entire reinforcement algorithm that definitely involves like more tasks and more time. And I think what's enables some interesting analysis is now we can like break down this curve first by work. So like across different domains of human work and across the different skills they're using. And I think one practical, or besides just, looking at how these different curves are distributed, another interesting implication, I think, for human workers or human who are actually using this AI tools is now like if you have a particular success rate in mind, or like if you expect the agent to perform like give you correct answers for like 80% of the time, now actually the useful thing for you to best utilize agents is actually, given the task you have, like find the right level of task complexity, like decompose your query into the appropriate level so that you can best or get the potentially higher quality outcome from these agents. And another interesting breakdown is like we can use this as a way to like, further analyze different agents, either by the agent framework or by the backbone language model that they're using. And you can see there are some curves which show like, oh, one bench framework is better than another. For example, also you see like general capabilities of these models on this task. However, I think particularly for like breaking things down for agent, it's still a challenging thing to collect a sufficient amount of agent trajectories to enable fair comparison on each of the benchmark and for us to report statistically significant results. So I think if your guys are interested, if you're running agents in any way, you're welcome to submit your trajectory to our database so that we can do more interesting analysis. So yeah, that's overall the content that I have today. Just as a summary, we first talk about, how the distribution of human work and agent development align or misalign with each other. And then for the tasks that currently AI are targeting, we do a head-to-head comparison of human agent workers. We analyze their performance in their workflow and their final task outcome. and finally how we could like on a higher level bridge the scores on those benchmarks to, their practical utility in different kinds of human work. So yeah, thanks for paying attention. Oh, I see a lot of questions already, so happy to answer those.
Thank you very much, Zora. That was absolutely wonderful.
Thank
I'll just
you.
stop recording and